this video, we'll talk more about some properties of differentiable functions that are going to help us calculate more of them and more easily. So the first is that if c is a constant and f is a differentiable function, then if we want to take the derivative of c times f of x, then that's going to equal c times the derivative of f of x. So here's how we want to think of that. We get to basically ignore the constants and just keep them along as we take derivatives. So if we want to use an example like we've seen before, if I have f of x equals 3x squared, and I want to find the derivative of this function, then by this theorem up here, this is going to be 3 times the derivative of just x squared. So what we get is the derivative of x squared is 2x, so we know that this is going to be 3 times 2x, so the derivative then is just going to be 6x. Along the same lines, the way we want to think about this sort of thing is, let's say I've got g of x equals 6 times the square root of x. Now, we know that this can be written as 6 times x to the 1/2. Now, how I want to think about this thing as I do it, so before we just brought the exponent down in front. When we have a constant out front, how we can think of it is I want to take the exponent times the thing out front. So I'd have 6 times 1/2, and then x to the 1/2 minus 1. And so this would become 3 times x to the negative 1/2. And as we do this, we get 3 over the square root of x. Now, another useful fact is that if f and g are differentiable, then their sum and subtraction are also differentiable. And we get to just take the derivative of the first thing plus the derivative of the second thing. So this lets us do things like polynomials. So if I have the function f of x equals 4x squared plus 5x plus 1, if I want to find the derivative of this function, well, I can just treat each piece separately in order to do that. So first I would take the derivative of 4x squared, and when we take the derivative of 4x squared, that 2 is going to come down in front, and I'm going to have 8. 2 times 4 is 8, and then I'll have x to the 2 minus 1, so that'll just be 8x. And then in the next part here, I want to take the derivative of 5x. Well, the derivative of x is just 1, so we know that this is going to be 5 times 1, because that constant just gets to come along. And then lastly, we have this plus 1 here. And so the derivative of that is just 0, because the derivative of any constant is 0. So when we go ahead and do this, we get 8x plus 5 as our derivative. Now, I'm going to write a couple down here as examples, and maybe you want to hit pause and try to do these on your own, and then check your work against mine. So I'm going to say g of x is equal to 5x to the 6th minus 3x squared plus the square root of x plus 3 to the 4th. And we'll take h of x to equal the function 4 over the square root of x minus 8x to the 3/2 plus x. So maybe hit pause here and try to solve these on your own. Well, so welcome back. We will go ahead and work these out. So when we start with this g prime of x, we're going to take the derivative of each piece separately. So first, x to the 6th, we'll bring that 6 down, so 5 times 6 is 30. And my new exponent will be x to the 5th, because I'll just subtract that exponent by 1. Now, with the next one, this 2 is going to come down front, so 2 times 3 is 6, and I'm going to have just the x here. And like I said, over addition and subtraction, we just get to do each piece separately. Now for the square root of x, we might want to remember that that is x to the 1/2 as we write this. So this is going to equal plus 1/2 x to the negative 1/2. If we do that little bit of prep work. And this plus 3 to the 4th. So I put the exponent in there to try to throw you off a little. Now this 3 to the 4th is just a number. It's actually equal to 81. So even though it looks like an exponent, it's a constant. So the derivative of that is just going to be 1. So when we finally write this out, we would have 30x to the 5th minus 6x plus 1 over 2 times the square root of x as we write it out. And for the second one, I'll go ahead and do the little bit of prep work that we would need to do. So I'm going to rewrite the square root of x here as a negative 1/2. So we'll have 4 times x to the negative 1/2, and then we'll have minus 8 times x to the 3/2, and then I'll just have this plus x here. So now as we take the derivative, we do it in steps here. So that negative 1/2 comes down. So I'll have negative 1/2 times 4, which makes it negative 2. And then I'll have x to the negative 1/2 minus 1. We'll come back to that. And then we'll have 8, and I'm going to do this in 2 steps here. So 8 times this 3/2 and x to the 3/2 minus 1. And then we'll just have that derivative of x, which is just 1. And as we clean this up, we'll get that this derivative is negative 2 times x to the negative 3/2 minus, okay, so the 8 times 3/2 is going to give us 12 here, and then I'm going to have x to the 1/2 plus 1. And so we'd have negative 2 and over x cubed, the square root of x cubed, minus 12 times the square root of x plus 1. And for one final example in this video, let's do the following problem where we want to find the equation of the tangent line to the curve y equals 2x cubed minus 4x at 1, negative 2. Again, maybe you want to hit pause here and try working this out on your own. So first we want to find y prime. So using our rules that we have here, we're going to bring down that 3. So 3 times 2 is 6. And now we're going to knock that exponent 3 down by 1. So we're going to have 6x squared minus, and okay, so the derivative of x is just 1. So we're just going to get 4 here. So if we want to find the slope of the tangent line, when x equals 1, we'll plug x in, and then y prime is going to be 6 times 1 squared minus 4, so we get 2. And now we can go ahead and plot this. So we're going to have y minus negative 2 equals 2 times x minus 1 using our point slope form and our point up here. So we'll have y plus 2 is equal to 2x minus 2. And so solving, we get y equals 2x minus 4. And again, let's just go ahead and pull up a graph to check this. And as we graph this curve, we see what we expect here. Here, purple, we've got our curve y equals 2x cubed minus 4x. Here is our point 1, negative 2, and our red line is tangent at that point to the curve.